Hello friends, aspiring pilots. Here I am back with you, SK Booty, with the tutorial on how to solve navigation numericals. Today we are going to take up numericals related to magnetism and magnetic compasses. As you know, there are two types of compasses: direct reading and remote indicating compasses. And the most prominent in use now is gyromagnetic compass, which is a remote indicating compass where you fly with the help of directional gyro, which is monitored by the magnetic element. Right? These are some of the general numericals which they will ask you: CPL, ATPL. Some other questions regarding and very important subject today, where the subject is not only a examination question, but you will be doing it day to day throughout your career in aviation. You will be solving these problems on the ground and in the air. On the ground during the flight planning stage. What is known to you, the track, either true or magnetic? In this question, I have taken track true, which is marked on your maps. And please make sure, confirm whether it's track true or magnetic, which is called a desired track or the planned track, which you wish to fly. Write it down here. In the air, if there is a track error, then the actual track made good true will be the one you will actually be flying. Then you will need to make a correction for the track error to remain on the desired or the planned track. Let us get back to the process of flight planning. Once you know your track and the flight level and the speed which you are going to get at that flight level, calculate the true speed. Then we will feed the planned track and the true speed to our nav calculator. It will give you a heading to fly as also the ground speed. The difference between heading to fly and the track which you wish to maintain is called drift. If you wish to maintain a track of 220 and the aircraft is going to drift 8 degrees to starboard, I will put my nose 8 degrees to port, and that's a wind correction angle, and fly this true heading, in this case 212. Then read the variation from your maps and charts, isogonals, line joining places of equal variation, and note down the variation in the area which we are flying. Variation is 1 west. Then I will fly a magnetic heading of 213 and read your deviation card. If the deviation is 3 east, I will fly a heading of compass heading of 210. When I solve this problem from left to right, east deviation and east variation is added. When and starboard drift is added. If I'm solving from right to left, starboard drift will be subtracted to get true heading. West will be added to true heading to get magnetic heading. East will be subtracted from magnetic heading to get the compass heading. Let me recheck from left to right to make sure that I have not made a mistake in calculation of this heading to fly. 210 plus 3. 213 minus 1. 212, drift is 8 starboard, so I will maintain a track of 220. And in the air, if I have a track error of 6 degrees starboard, then I'll be on a track of 226. This is done in the air and we will correct in the air. During the flight planning stage, there is no track error and the track made good. Your track true is the one which you want to make good or fly in the air. If your true heading, track true, you apply the drift, you get heading true. And if it's a track magnetic and you apply the drift, then you will get magnetic heading. So magnetic heading plus minus drift gives you magnetic track. True heading plus or minus the drift gives you true track. True heading, when do we add? If the aircraft is going to drift to starboard, that means my track will be to the starboard. And here is another example for you for your practice. 355 is my desired track. Drift is 10 degrees to port. So I'll fly a heading 10 degrees to starboard. That will be 365, which is equal to 005. Right to left, east will be subtracted. 005 minus 6 east will give me 359. 005 can also be treated as 365. Minus 6, 359. 3 west, it becomes 362, which is 002. So 00, 2, 3, 4, 5 can be written as 361, 362, 363, etc. for mathematical calculations. What is variation? Variation is given to you by reading the isogonal lines joining places of equal variation which are drawn on your charts. From there, you will read your drift, or I beg your pardon, variation. Whereas deviation is calculated through a process known as compass swing. We will not go into detailed theory of the compass swing, but the numericals which are asked regarding the compass swing generally relate to how is coefficient B, C, and A calculated. And this deviation, let us say 3 east, this is the total deviation on magnetic heading of 213. This deviation theta on heading theta is equal to coefficient A plus B sine theta plus C cosine theta. Remember, the theta in this case is our heading. You want to solve the numerical. If the heading is given to you as 220, then write down division on heading 220. Coefficient A will be given to you, B will be given to you. In the exam, C will be given to you. Or he may ask you to calculate ABC with these equations. Then A plus B sine theta, and do it in the brackets. If B is minus, sine theta is minus, then minus into minus becomes plus, and use your algebra properly. Next, this is the deviation which we use in the air. Deviation on heading theta, which is given in the deviation card prepared for you on the ground through a process known as compass swing. Now, for the compass swing, first we rotate the aircraft on the ground at a place which is called compass swing base and find out coefficient B and C. First, the aircraft is rotated on 4 cardinal headings, that is north, east, south, and west. You can do it clockwise or you can do it anti-clockwise. Let's do it. Let's say the aircraft is parked here on the compass wing base, and the pilot turns the aircraft on the ground towards an approximate direction of north, plus minus 3-4 degrees. Don't burn your brakes trying to bring exactly 0, 0, 0 on your magnetic compass. Fine. Let's say here the pilot reports that my compass heading is 359. The person standing outside with the medium landing compass, which is the master compass, calibrated compass, tells you that he will take the direction of this aircraft and tells you that my reading, MLC reading, which gives you the magnetic heading, is 002. It means on this heading, my deviation is plus 3. So that becomes deviation on heading north. Then pilot will turn the aircraft towards east. MLC will be brought here in front. You return towards south and west. On these 4 headings, you take the readings and you will find your coefficient B and C. Now we have already taken coefficient on or deviation on heading north at the moment. We have one deviation with us. Deviation on heading north is plus 3. Now take the aircraft on heading east and take the reading. Keep that reading with you. We will use it later on. And when the aircraft is taken to heading south, and let's say what are the readings we are getting? The pilot reports a compass heading of 180, and the magnetic heading reported by the person outside here by his medium landing compass is 177. Now on heading 180, south heading, your deviation is minus 3. Solve CDM. In the examination, sometimes he will give you magnetic heading first. That magnetic heading is 177, or the medium landing of the master compass is 177, and the aircraft compass reads 180. Again, solve CDM. And deviation will be minus 3. Don't get trapped in solving from left to right or right to left. Solve CDM. And this case I find deviation on heading south is minus 3. So plus 3 minus minus 3 will also become plus 3 divided by 2 plus 3 becomes your coefficient C. Okay. So what do? We correct for this coefficient C with the help of a micro adjuster. Or electromagnetic corrector in your gyromagnetic compasses. And then we will proceed forward. At this time, your magnetic heading is 177. After applying the correction, your compass should start reading, your compass heading is 180, I beg your pardon. After applying this correction, your compass should start reading 177. That means coefficient C has been corrected, right? Now let's go a little further. Let's say we had similarly noted the deviation on heading east as plus, or rather, okay, -4, let's say, and deviation on heading west is +2. So -4 minus +2 becomes -6 divided by 2. It just so happens that coefficient B is -3 degrees. And now we will correct for this coefficient of -3 degrees. At the moment, we have reached heading west. So on this westerly heading, with the help of a adjuster, micro or electromagnetic corrector, we will correct our coefficient C. So these questions are often asked. What is coefficient B? What is coefficient T? Deviation on heading east minus deviation on heading west divided by 2 is coefficient B. And deviation on heading north minus deviation on heading south divided by 2 is your coefficient C. After these two coefficients have been corrected, so far what we had carried out was correction swing. Coefficient B and C have been corrected. After that, we will check, are there still any deviations left over? So this process will be carried out again by rotating the aircraft on either 8 headings 45 degrees apart or 12 headings 30 degrees apart, north, northeast, east, southeast, south, southwest, west, northwest, and complete your 8 headings. Similarly, calculate deviation on heading north plus northeast, east, and add them up algebraically and divided by 8. You will get the average coefficient on all these headings, and that is called coefficient A. And if you take on 12 headings 30 degrees apart, then add them up and divide it by 12. So we divided by 12 in that case, number of headings. And you get coefficient A, which value could be plus or minus, and the coefficient A can be corrected by moving the lubber line. Okay. And on the electromagnetic correctors, you will move the detector unit itself. The correction is applied at the detector unit itself, or aircraft which have got a variation setting control, you can apply the correction on VSC. I am not going in these details which are covered in theory. And right now we are going to concentrate on numericals. I hope you have followed it. You have noted them down in your diary, and you are ready for practice questions, 1 or 2, which we will do now. Stand by. Just give me a moment. Patience. In the meantime, you can read this slide and prepare yourself for one or two questions which we are going to do for practice now. So there you are. CDMBT drift track true. If you apply the drift to the magnetic heading, you get magnetic track. If you apply it to the true heading, you get true track. And similarly, to the true track, if you apply the track error, you will get track made good true. If you apply it to the magnetic heading, you will get track made good magnetic. And please remember, your flight planning stage, we work up to here, and this will be applicable only in the air. So this portion will be applicable if you have a track error in the air. If there is no track error, if your winds are correct and you're flying the correct compass heading and your deviations are correct, variation has been applied correctly, then your aircraft will remain on track, and that's a life made easy. So this flight planning stage, be careful, don't make any mistakes. But winds are not in your hands, unfortunately, not till today. Okay, so winds, of course, sometimes the winds predicted are very good, and sometimes, for reasons unknown, the Met Officer is not able to predict the correct winds. Don't blame them. They have their own limitations. They have their own equipment, and the weather is a changing factor. They are preparing their briefing on what has been the weather pattern, and you are traveling into the future. There are things which can change the weather which was predicted for your flight. Okay, so we will correct for it in the air, and that's what you are paid for. If there is, if you are not on track, correct for it. Because you know, if you go little bit more than your desired track, you may find the fighters of that country escorting you from left and right. You have to maintain your track and within limits. And there are reasons are two. Number one, the security considerations of the country over which you're flying. And second is the safety considerations of the traffic. You are not the only one in the air. There are other aircraft also flying to your left, right, above and below you. So try and maintain as accurately as you can and use all navigation aids available at your disposal for maintaining your track. And if there are changes in the ground speed, don't forget to inform the changes of ETA to the appropriate ground control, and your flying career itself will progress smoothly. There is no scope for errors, and because there are people sitting behind you and everyone values is right. So be kind to them. And what do I mean by be kind to them? Be kind to yourself, brush up your knowledge, keep updated with the knowledge, use all the navigation equipment and the knowledge at your command, and make every flight a success. Right, that was too much of a moral lesson. Let's get back to navigation now and do a few practice questions. Okay, now let me clear this screen. Okay. Now I'm back with you. And we have done numericals connected with the track, drift, variation, deviation, etc., which is a part of your flight planning as well as in the air. And not one, but there will be number of questions in your paper concerning CDMVT. So when you enter the examination hall, write down CDMVT somewhere and keep rubbing one question, go to the next one, third one. You don't have to every time write fresh. So prepare this CDMVT with you. And let us say, I will now prepare it with you. C means compass heading, deviation, magnetic heading, variation, true heading, drift. Then you have the track, planned track or the desired track. And if you have a track error, then the TMG will be different. Now, let me give you some questions. Let's see how far you can do this properly. Magnetic heading 0, 1, 0. Variation 6 west. Deviation 2 west. Drift 6 degrees port. Right. Calculate compass heading to fly. What will be the aircraft track? True and track magnetic. Let me help you with the first one. Then I'll give you a few for the practice. Write on whatever information is available. Magnetic heading 0, 1, 0. Variation 6 west. Deviation 2 west. Drift 6 degrees port. Now, what does he want? Compass heading 0, 1, 0. Since I'm going to the left, then west will be added 0, 1, 2. From left to right, deviation west is subtracted. From right to left, west will be added. So 0, 1, 2 will be my compass heading. Now I'm going from left to right, west will be subtracted. So my true heading will be 0, 0, 4. 0, 0, 4 is my true heading, and I'm going to drift 6 degrees toward port. So my track will be 6 degrees to the port of my heading. 0, 0, 4. This is 0, 0, 4. And my track will be 6 degrees to the port. So it will become 364 minus 6. My track will be 358, and this will be the track true. If he wants track magnetic, MVT. MVT. This is my true track 358. If I apply the variation here 6 west, I will get true track, magnetic track. Solving it from right to left, west will be added. So magnetic track will be 0, 0, 4. Or to the magnetic heading, I can apply the drift. Magnetic heading is 0, 1, 0. I'm going to drift 6 degrees to the port. So my magnetic track will be 0, 0, 4. You can apply it either to the track true, MVT, or MVT to the magnetic heading. And you will get track magnetic. So your have all your three answers with you by now. Okay. Wait for a few seconds. One for your homework. Aircraft is flying a compass heading of 001. Deviation to west. Variation 12 east. Drift 8 degrees starboard. Complete CDMVT. And in the air, if there's a track error of 4 degrees to port, complete this table CDMVT up to track made good. And best way to check it for the time being will be two of you can sit down together, do it. If there's a difference, come back to me. Otherwise, if you are able to convince yourself that, yes, I've made a mistake, then correct your answers and you can do some more. And at a later date, I will be also giving you some more. I'll be adding the question bank also to my lessons. But stand by for the time being. I'm doing only the numericals for you. Second set of numericals may deal with the angle of dip. Let's say this is the Earth. This is the magnetic equator, magnetic north, and magnetic south. And the aircraft is flying towards north. Over magnetic equator, your compass needle will be horizontal because on the magnetic needle, South Pole and North Pole are exerting equal force. This is the horizontal force. Magnetic needle will be horizontal. As I go towards the pole, my needle starts dipping from the horizontal. And at pole, it becomes vertical. It will be telling you, here is your magnetic north, and you are traveling like this. So at the equator, horizontal pole is maximum, and I'm talking about magnetic equator. At the pole, the vertical force is maximum and magnetic needle becomes vertical. Anywhere in between, your total force acting on the magnetic needle will give you a angle dip theta. Okay. So sometimes they do ask you questions on this concept. Remember, at magnetic equator, Z is 0, vertical force is 0, and H is maximum. At pole, Z is maximum and H is 0. There is no horizontal force. And therefore, a normal magnetic compass cannot be used over the pole. The value of horizontal component is 0, which gives you the direction. The angle between the horizontal and the direction taken by the needle is called the angle of dip or theta. Now your value of Z is T sine dip. Sine theta is 90. Your total force, I beg your pardon, vertical force is total force, and at pole theta becomes 90, so Z becomes equal to T. At any other place, it will be equal to T sine theta. Similarly, H starts decreasing as you go towards pole and varies as cosine theta. At any other latitude, it will be T cosine theta. Theta is the angle of dip, and value of Z by H is equal to tan dip. So there are four variables, Z, T, H, and the angle of dip theta. Out of these four variables, if two are given to you, then you can calculate the third, and from the third, you can solve the fourth question. These are the four possible numericals out of this concept of the angle of dip. Okay. Time to sign off for today, and all the best. Good luck till we meet again for the next lesson. Today we have done the numericals on magnetism. Okay, bye-bye. Good luck. Signing off now.